Start with the first session. I'm very happy that Konrad Kuijken from Sterrenwacht Leiden is going to chair the first session. I'm also very proud that I can say that I worked with him for many, many years on the KITS and now on the Euclid project. So I'm really proud to present Koen, who will chair the first session. And let's take off from there. Koen, it's yours.
Thank you, Edwin. Welcome, everybody. I won't say good morning, good afternoon. I'll just say good day. Given that we have a speaker from Australia, I think that's very appropriate. There will be 3 speakers in this first session. Each speaker will be introduced by someone, and then we will have about 10 minutes of questions. And so you should all have a raise hand button on your Zoom screen. So if you want to ask a question, then please, during the talk, raise your hand on that, using that button. And then at the end, I will call upon you to speak. Okay, so the first speaker is going to be introduced by my colleague, Professor Alessandra Silvestri from the Department of Theoretical Physics, the Institute Lawrence here in Leiden. Alessandra.
Yes, hello. Thank you, Koen. Good afternoon or good day, everybody. It's my pleasure to introduce the first speaker, our first keynote speaker of today, Professor Charles Lineweaver. He holds a joint professorship at the Research School of Astronomy and Astrophysics and Research School of Earth Sciences in Canberra, Australia, where he's also the convener of a very interesting endeavor, which is the Australian National University Planetary Science Institute in Canberra as well. If you allow me, I'll say Charles instead of Professor Lineweaver, just to make it less formal. So Charles received his PhD in astrophysics from the University of California, Berkeley in 1994. He was, I think back then, a member of COBE, the satellite that made the groundbreaking measurement of the fluctuations in the radiation of the cosmic microwave background, which I think pretty much basically set the foundations for modern cosmology and most of what we have learned about our universe. Nowadays, his research interest spans from cosmology all the way to evolutionary biology. And I think complexity is what is the thread that joins these 2 fields that might sound quite separate. And his research interest passes also through astrobiology, exoplanets, and all that has to do with complexity and life. I think today he will tell us about the role of biological information, and most of his research keeps a particular eye on the role of complexity, role of time, and the role of life. I think that's more or less what I wanted to say. It's my pleasure to welcome you, and I'll leave the floor to you. Welcome.
Thank you very much, Alexandra. Can you hear me? All right, so I will try to share my screen. Well, first of all, thank you very much for that introduction. I will now share my screen and click on a few buttons and share. And you're now sharing this. And so am I seeing, are you seeing my first slide?
Yes, we are seeing, I'm not sure if I'm the one or Koen should be the one. We're seeing
okay.
The slide, yeah.
No,
so eat, survive, reproduce, eat, survive, reproduce. You can see that? All right.
Yes.
I will assume that you can. All right.
All's good.
All right, good. So we are concerned, we are animals that when we have evolved, and we used to be very concerned about hunting and gathering, and then agriculture, and now in industry, and now we seem to be obsessed with information. And I'll be talking about information today, and specifically, I'll be interested in the topic, is biological information the only kind of information? I hope this is mildly provocative to cosmologists who don't want to have anything to do with biology, because I think we need to talk about biology, because it is possible, and I'll be making the case that biological information is the only kind of information. So let me make some heretical statements. So the origin of biological information, I think, is the origin of all information. And what do I mean by that? Well, as Alexandra mentioned, I studied the black body radiation. This is a map of the full sky of the microwave background radiation, but there are no fluctuations in it because this is the scale in which it doesn't show fluctuations. Now, this is as close to equilibrium as you can get in a quantum world. Then comes galaxies. The overdensities collapsed into galaxies and stars. Then later on, we had complex environments. You can say that they are far from equilibrium, full of free energy and gradients that select and enable molecular evolution. And then we have something called ribozymes. These are information and catalysis. Then we have chromosomes and their DNA. And then we have brains where we also store information. So that's an overview of biological information and how it got into the universe. But how did the universe change from a simple hot gas of photons, i.e. the CMB, the cosmic microwave background, at equilibrium, completely incapable of supporting life? How did it then turn into a complex environment able to select and enable molecular evolution? That's the image on the right, the microwave background on the left with no galaxies. So here's the question. How did we go from the CMB, the cosmic microwave background, equilibrium, maximum entropy, to a kangaroo? That happened in our universe, on our planet. We want to know how. So one way to understand this is, the big picture is to talk about inflation and the origin of structure. So at the bottom of the plot, you see at about a very small scale, 10 to the minus 36 centimeters. No, these are meters. You have random quantum fluctuations. And the best explanation we have for the origin of the large-scale structure in the universe is that those random quantum fluctuations were inflated and produced large-scale structure, which then showed up in the microwave background, which then the overdensities then collapsed to form large-scale structure, which then formed galaxy stars, Albert Einstein. And then you can also see an electron in an iron cage at about 10 to the minus 10 meters. So that's a very large scale of sizes on the left there. And inflation seems to have produced out of quantum fluctuations, large scale structure. So random quantum fluctuations inflated during inflation, producing density inhomogeneities who gravitationally collapse to form all the structures in the universe. How can random fluctuations produce information? What information is there to be found in a distribution of random numbers? Unless you are one of the numbers. There's a number. A lot of information in that number. Look at that. So this is, some people often think about pi in this context. There's pi 3.14159, blah, 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 blah. And at the end of Carl Sagan's book, Contact, Ellie Arroway, the main character, is looking for information from God in the random digits of pi. And this is kind of strange, I think. But also, you can log on to wolfram.com and find your birthday in pi. As a matter of fact, you can do that right now. Find when in the digits of pi the digits of your birthday occur. I can guarantee you that that's the case. You can interpret it as you being inside of pi or not. I'll let you decide. So what is information and where is information is something that's not easy to answer. Now, there's a book by Daniel Dennett called Darwin's Dangerous Ideas, and he says basically that biological evolution works with cranes. It works from the bottom up. But some people are enticed to say that, no, there are sky hooks. And there's a sky hook on the right where you can say, oh, what's lifting up are the laws of physics or God or math. Somehow these are things that did not evolve, have always existed, maybe existed pre-Big Bang or in some space that is somehow transcendent. It's a little bit like the debate in math about whether math is discovered or found, or discovered or invented. So about, I don't know, 30 years ago, I got into conversations with people. As I was studying physics, I would sometimes arrogantly say that all biology can be reduced to chemistry and all chemistry can be reduced to physics. So physics is the basis of everything. But then my father, who's a biologist, said, it doesn't stop with physics because all physicists are biologically evolved organisms. Therefore, biology is the basis of everything, not physics. And there's another astrophysicist, Tamara Davis, who says physics is the basis of everything, but math is the basis of physics. To which I think my father would answer, but I'm pretty sure mathematicians are all biologically evolved organisms. So the point is, when we're asking the question, what is the basis of everything? Physicists think physics is, but biologists think that all you physicists are biologically evolved, therefore biology is the basis. And I guess I'm shifted over time onto the side of the biologists on this issue. Another way to ask this question is, does a dictionary without a reader have any information? So here's a dictionary floating in the ocean. And if all readers die, I think you could argue that the dictionary no longer has information. In some sense, information is not an object. It is a relation between the world and a life form. So if that's true, there can be no information without a life form. Then biological information, or information useful to biology, is the only kind of information possible. So if there is information in the forest and no one knows it, is it information? There's a question for you. So is there a way to talk about information without the existence of life before the existence of life? I don't think there is, but cosmologists do this all the time. Before cosmologists, were the positions of these galaxies information? Is another way to ask that question. Now, I went to grad school with Max Tegmark. Here is a picture there. And he wrote a paper in 1996 called, "Does the Universe, in Fact, Contain Almost No Information?" It's an intriguing title, and I can recommend it. And in this, it says, one of the most striking features of the universe we inhabit is its complexity. When going swimming, after setting up an overnight hydrodynamics batch code on the computer, it is easy to start marveling over the system of currents, waves, vortices in the pool, and ask oneself silly questions like, how on earth can nature calculate all this in real time? Well, does nature calculate, or does nature process information according to the equations we use to process information? I think that that's probably not the case. It does it too easily. I don't think there's a processing going on. It just is. And I'm not quite sure exactly what that means, but I'm pretty sure that nature does not calculate to produce the lovely patterns at the bottom of a pool. Here's one way to understand that. Suppose there's a uniform probability distribution, and we can say that there's almost no information there. But let's suppose we choose a specific number out of that distribution, and there's one listed on the top of the screen, and there's an infinite amount of information is required to specify any given number. So that's the sense in which the whole is less than the sum of its parts in terms of complexity. We can make this even simpler. He said, instead of almost no information, let's make our distribution like that. Then instead of almost no information, we have less than almost no information in the distribution. We still have an infinite amount of information in that specific number. So here are the galaxies in the Hubble Deep Field. Here's some stars. And we can ask, I think we can say that there's no viewpoint independent information. There is no information except from a viewpoint. And the green dot there represents the position of the sun in the Milky Way. So later on, Max wrote a book in the lower right there, Our Mathematical Universe, and he said, information isn't fundamentally about our physical reality, but about our place in it. So now he realizes that he should have dropped the word almost, and that's the conclusion he came to, that there is no information in the universe. Now, to give you a simple example of this, sometimes I've been lost on campuses, and here's a campus map of Groningen. And if there is no "you are here" indicator, that map provides you with no information because you have no idea where you are and you need to know, you're trying to find your way somewhere. But if you don't know where you are, you don't know, there's no information in that map. So I think the existence of information depends on not only position, but the existence of contrafactuals on what could have happened but didn't. In other words, there's a ratio, what is the case, divided by what could have been the case. When you flip a coin, there are two possibilities, 1 out of 2. When you roll a die, there are 6 possibilities, 1 out of 6. When you write a letter of the English alphabet, there are 26 possibilities, 1 out of 26. When you write a Chinese character, there are about 5,000 possibilities. So the probability is 1 out of 5,000. So these fractions are a measure of information or the reduction in uncertainty. But if the coin has only one side, the ratio is 1 to 1 and there's no reduction in uncertainty. So The motto is, you get no information by flipping a one-sided coin. Now here's Einstein with Charlie Chaplin. And the question I want to address briefly is, are the laws of the universe a one-sided coin? And this is also something that Einstein, probably his most quoted phrase was, what really interests me is whether God could have created the world any differently. Did God have a choice? In other words, was there a mother distribution from which the laws of the universe were chosen? And if there isn't a mother distribution, then maybe we're talking about a one-sided coin. And as we said earlier, you get no information by flipping a one-sided coin. Sometimes I've heard people like Richard Dawkins and Carl Sagan say, you are lucky to be alive. Just think of all the people who haven't been born yet. Well, here's the ratio of how lucky you are. 1, you, divided by the number of people who haven't been born. But what in the heck does that mean? How many people haven't been born? I don't know. That seems like a very poorly defined concept. So if we have what is the case divided by what could have been the case, in a world in which the number of contrafactuals determines the amount of information or reduction of an uncertainty, it remains plausible that what is the case divided by what could have been the case is 1 divided by 1, in which case there's no information in the way the universe is, unless you insist on imagining that the universe could have been different. Now, this is also something that John Wheeler, and he talked about it from bit. And that means that the universe came into existence somehow from information, somehow from that skyhook of math, or the laws of physics are somehow outside of the universe. But when you study biological evolution, I get more of the feeling that bit information comes from it, and you can only have information when you have it. Now, I want to, at the end of my talk here, I want to show the video. It begins slowly, but I want you to imagine that if a computer can see this much information in Van Gogh painting, imagine how much information we can see in an island of the multiverse. So here's the video. I hope it plays. Okay, well, that is my talk. I'm not sure how I'm doing for time. I think I'm ahead of time here. But I guess the main thing that I want to say is that you can't have a view except from a viewpoint. And having a viewpoint is what puts the information in the universe.
Thank you. I think we can consider this to be a virtual applause. It's always a bit strange these meetings. If people would like to answer questions or start a discussion, please raise your hand using the Zoom button, and I will switch on your microphone and let you ask a question.
Don't I get to be the head on the screen?
You are the head on the screen. You are the head on my screen.
Oh, is that right? I see you. I see. Okay. All right. Good.
Maybe I can start. You started off with the CMB as being something which contains a minimal amount of information. Now, as a cosmologist, I would say that much of the structure that formed since is a result of gravity. It's the gravitational instability that pulled everything away from equilibrium. So does this give a kind of deep link between gravity and biology, would you say, if I take your arguments to the extreme?
Well, I would say it gives a deep link between gravity and entropy. Now, one of the main issues with when we look at the CMB, we say, hey, look at that. It's a black body spectrum. That is equilibrium. That is maximum entropy. And so we have to say, well, wait a minute, that's impossible. The second law is inconsistent. The universe cannot start at maximum entropy and then have life forms in it. So Penrose and others have talked about how a universe that has an evenly distributed mass, approximately evenly distributed mass, is a situation of low gravitational entropy. In other words, we can't just consider the entropy of the universe to be equal to the entropy of the CMB. We have to include the gravitational entropy associated with an almost homogeneously distributed mass, because what happens then? Well, then things start to clump. And then they clump and clump and clump even more. And then when they clump into black holes, for example, you have an enormous amount of entropy. So there has to be an entropy term. We do not have this mathematically fixed up yet, but there has to be an entropy term that says you start out the universe at low entropy, evenly distributed matter. And then as the gravity clumps the matter, you get higher entropy and then eventually black holes. So yes, there is a connection between gravitational accretion, gravitational contraction, and the entropy of the universe, which has to increase given that term. The CMB does not increase the entropy of the universe and is completely unable to do anything, because any environment that is at equilibrium cannot be an environment that selects things here, selects things there, and can produce natural selection and get life started.
There's a question from Edwin, I understand. Go ahead, Edwin. I see you've opened your mic.
I tried to start my video. Oh, I cannot start video, but I can start my microphone. Okay. I just noticed on your emphasizing in your talk a lot that the viewpoint is an important criterion in what determines what information is, and I agree, but a little bit in a different way. In the book, I can find the phrase many times: information only exists when it's being copied. And in the end, that's probably the same. We mean the same, right? Because the viewpoint is in the end that you copy it from the source to the viewer.
Well, yes, I think it's not, I wouldn't say copied. I would say when it's being used, when it has semantic information that is useful to a biological organism. In other words, when you talk about copying, you're assuming that a copying mechanism has evolved. That can only happen biologically. You didn't have copying mechanisms before there was life in the universe. That's what I would maintain.
But if I look at the stars, I do the same, right?
Well, that's from your position. And if you were looking at the stars from all positions, then it would be more like you're looking at the distribution of stars, and there's a lot less information in the distribution than there is in any specific number in that distribution.
Okay, no, I understand, but I was just meaning it's not what you say is not exclusive for life. It's also it could apply to any information.
No, I don't. So I'm trying to make the point, and I'm arguing in this lecture.
That's why I'm asking the question. Thank you. Tell me.
Yes,
tell us.
I'm arguing that information doesn't really exist without a viewpoint. And you said information doesn't exist without being copied, but any copying mechanism you can imagine has to have evolved. And therefore, only after you have evolved the copying mechanism, and why would you do that? Well, you would have a biological organism who wants to find out something to stay alive. that's when information becomes useful, and only information has the connotation of being a good thing that's useful, but you can't use those words unless you are a biological organism, because mountains don't have uses, and wind doesn't have it, and a photon doesn't, but biological organisms do. And so I think we need to remember that's the main context for what information, in other words, information is not an object. It's a relationship between, well, it's a relationship between, I guess, DNA, for example, and a reader ribosome, or the universe and ourselves.
Sure. Thank you. Thank you, Charlie. Perhaps some other questions?
There's another question. There's one from Max Welling, and you can talk.
Yes, I have also a question. So the first question I have is, does it have to be biological? Could it also be artificial intelligence? And the other question is there a relationship to Bayesian statistics, or in other words, the subjective view of the world, right? That we do inferences only on a personal basis. The world is subjective.
Okay, so those are two questions. One is about the artificial. Can the intelligence be artificial? Can the life form be artificial? I don't see why not, except for the fact that there's a debate now about whether intelligence can be substrate independent or not. And I think the majority of people who work with artificial intelligence think, yes, it can. And the problem with that idea, and so the idea is you can take what intelligence you have in your brain, you can upload it onto the computer. I am very, very skeptical of that because of the historical nature of the evolutionary path that led to the type of structure you have inside your brain. So I think we reify, we make what we have called intelligence too abstract a quantity. It is integrally, it is an organ inside our body, and to pretend that it somehow could exist outside is kind of silly, because it takes away all of the emotional content, all of the rational content too, because all that is based on 4 billion years of evolution, of which we are part. So I think when you talk about, artificial intelligence, can it have meaning? Because as long as, if you have evolved something that again and again and again has been selected to want to be alive or to be alive, then yes, artificial life forms can have agency, if you want, or they can be considered to be official life, life forms in their own right. But that requires so much background in history and evolution that I think that what we now call artificial intelligence just doesn't have that, because we pretend that we can create life without realizing that life needs to have that historical evolutionary background. And that's one of the challenges that people who are trying to make life in the laboratory are coming up with. They keep asking the question, what's the minimum amount of information I can put into a life form and still call it life? And I think the answer to that question is there's zero. You can have less information, less information, less information, and then you become chemistry, far from equilibrium chemistry. And what was the second question you asked about? Bayes' theorem. Bayes' theorem, yeah. Well, Bayes' theorem is trying to get an objective assessment, and then it uses the prior, which is the subjective assessment. So what I'm challenging here is that there is such a thing as a viewpoint independent reality. And all the information that we're after is dependent on our position in the universe and our position as life forms there. I know this is a little bit of a philosophical issue that it might be interesting to straighten out for people who are philosophically inclined like myself and some physicists, but not everybody's cup of tea.
Thank you.
There's another question from Johan Hidding. Go ahead, Johan.
Yes, thank you. It was a very interesting talk, and I also liked the Van Gogh imagery. So my question would be, if information is nothing without an observer, could like the physical process itself, like gravity, be an observer in this sense, that it applies a new context to the CMB that was first generated in a more statistical physics, gas physics kind of way?
Well, I think as cosmologists, we're used to describing, the evolution of these densities in the universe, but I think the gravity does not have a viewpoint. I think we have a viewpoint, and that viewpoint, that specific place in the universe, is what makes all the information around us. I don't know if you've read Max Tegmark's book, but I can recommend it to try to get into some of the details of why, when you take an ensemble view, like that probability distribution of uniform distribution, and then you pick one number out of it, i.e. you put yourself in a position, that putting yourself into position is what has an infinite amount of information in it. But the distribution, the whole, has very, very little information in it. And that's the viewpoint that, it's kind of like the bird's eye versus the turtle's eye difference. And you can ask yourself about Bayes, or when you're doing Bayesian theory, are you doing a turtle, a bird, or some mixture of that? Because you're trying to get to the bird's eye view, but the prior that you have is a more of a turtle, deep in the mud view. But I think this problem is worth thinking about, because we all, I think all too often think, oh, the information is out there in some objective way, and then we neglect, we marginalize our sense as observers.
But I would say that the meaning of this information is also like we have no freedom to choose it. I mean, it's implied by the physics. So in this case, the physics of gravity.
Yeah, well, that comes to one of the points I went over very quickly, and that was Einstein's question: did God have a choice in choosing the laws of the universe? And if the universe had to be this way, then that ratio of 1 to 1 is flipping a one-sided coin, and that there was no possibility for any other way, and then there is no information in the way the universe is.
So if you go back to this Van Gogh images, you started with completely different paintings, but the end result typically was the same every time because of the process.
I think that's like people are so attuned to looking at faces that we see faces in almost everything. But I'm sure that had to do with the intricacies and details of the computer, what it was told to look for, and you find what you look for often.
Thank you.
All right, there's plenty more questions coming up. The next one is from Mr. or Mrs. Chatterjee.
Oh, yes. Hello. Beautiful talk. I have a point here to mention about this, the perspective dependence. So it's a little bit philosophical. You just mentioned that what we have in the contemporary philosophy, that the object-oriented ontology, you must be aware of this, that we are trying to go beyond the subjective objective dichotomy, that everything is dependent on the perspective or the subjective view. So it kind of clashes with this thing that when we look at everything as an object, and there is this, the ontologically speaking, that every object has its own right to exist, and it has its own information by itself. But rather, when two objects, they have a relation, so there might be a relational perspective, there is always, because of the observation or any measurement that is happening. So could it be that we are only looking at the relational side of this information, but maybe there is something that is hidden in the objects that is always undermining from us, from all our observations, from all our relations that we are perceiving, or perception is a little bit less accurate word, relation. So what I'm trying to say is that have you ever thought about these things, that what's going on in the contemporary ontology, in the philosophy, it's called speculative turn, and how that actually can be related to this new definition of information? Because this is it goes back to the Kantian philosophy that everything is subject dependent, and this is not exactly what we as objective scientists try to establish, right? So epistemologically. So do you have anything to talk about?
Yeah. Let me say a few words about that. Now, so you use two words. One is ontology, the way things are, and epistemology, the way we find out things.
Exactly.
Now, and so epistemology, I think, is really important, and because I think we have these brains that create a whole imaginary world of how could the universe be?
Yes.
And then we spend our time as scientists eliminate, oh, it's not like that, it's not like that, it's not like that, oh, it's like this. Yes. And so that's essentially what we do as scientists. We make models and we test them, and we eliminate the contrafactual imaginary world that we've created in our brains. That's how we find out things, and that's how I think it's one of our wonderful adaptations. But I don't think that the universe necessarily could have been the way that we can imagine it to have been. In other words, our contrafactual world is a tool for us to come to realize how the universe is, but that doesn't necessarily mean that the universe could have been otherwise than it is.
Yeah,
and
so
that
universe
ontology and epistemology is an important one.
Yeah, so universe, what I'm trying to say is that we are the sentient beings trying to model our universe or whatever we are perceiving, but universe has its own right to have its own existence as a being as it is, and its own information independent of any other object to be having any relation with it, right?
Well, there I would have to disagree with you. You say objects have a right to exist. I don't think it's appropriate to I don't agree with what you just said. Let's just say that.
I know it's a bit too much, but sometimes it's so I just try to find out whether this information definition of information based on the relation and the perspective dependence, whether this is actually an epistemological problem or actually it points out to a deeper ontological quest. But maybe I should stop here now. It might go too far in philosophical, but really nice perspective. And I think there is a huge philosophical potential in it. So that's all I'm trying to say. Thank you.
It's a can of worms. Thank you.
Let's take two more questions before we move on to the next speaker. The first one is from Alessandra Silvestri.
Yeah, thank you. Thank you, Charles, for this thought-provoking talk. Just two observations. One, your proposal seems to me could be labeled as the theory of informational relativity, with obvious connotations to the theory of relativity thought up over a century ago. And number two, if there is some sort of a setup, let's say there is a transmitter emitting a signal digitally coded with certain bit rate, there is energy flowing through that channel and there is information flowing through it. Now, there are maybe two kinds of information. One, the physical one, like I said, some bit rate, and the other one is the perceptual one, saying if that is an announcement of one alien culture to the other, to the receiver, it would be a huge elimination of uncertainty, and that's a huge information quantity received at the first instance. And then maybe it diminishes or not. So there are subtleties here. And I was wondering whether you talk about these things to philosophers and what do they say? Thanks.
Well, I had a slide in my talk that I unfortunately took out, and it had to do with Claude Shannon. And Claude Shannon is known as the father of information theory. And he wrote a paper, The Mathematical Theory of Information, 1948, in which he talked about the transmission of information. And it was interesting because he was not talking about semantic information. He was talking about the transmission of anything that didn't have even 1, 1, 1, 1, 2, 2, whatever. It didn't have meaning necessarily. And the biologists, when they heard about this, they said, well, wait a minute, we're not interested in transmission engineering. We're interested in semantic information that can be used to help us survive. And so I guess one way to say the problem is irrelevant information information? And I guess I'm taking the point of view that no, we shouldn't call irrelevant information. It is just some kind of noise that we don't care about, and there's no information in it unless there's somebody or something. I don't want to say just sentient beings. I think anything that you could consider alive or half alive for all I know. But the point is that if we talk about the emergence of life and the origin of life, and then we have an agent or something, then we have to talk about the emergence of information. If it's a relation between something that needs information to survive and the universe, then that relation evolves as the life originates. So that would be the origin of information at the same time.
Thank you. And the final question is from Avri Silik.
Okay, thank you. Can you hear me?
Can you speak
I
up?
can.
Okay, thanks. Very interesting. And one of the things I wonder is well, if information is nothing without an observer, it reminds me of the Einstein-Podolsky-Rosen paradox, where actually Einstein tried to prove that there is information without observing, but quantum mechanics turned out to be right. And if you extrapolate that, I don't know if that's allowed in the universe. So quantum mechanics extrapolating in the universe is difficult. But at the moment you observe, the universe is not fixed. Because then, in that similarity, it means that one part, when one part you observe, but the other part will be uncertain. And that could mean that at the moment you observe that there are various possibilities to form the universe. That's my theory, I thought, in the last 10 minutes.
Okay. Yeah. I guess my comment on that is, I didn't mean to imply that you needed an observer for there to be information. I guess, for example, bacteria, for example, sense the world. They get information. That information helps them. They can swim to through a salt gradient or not. And that is certainly information. And very few people would say that they are observers. So I want to back away from the type of subjectivity I was talking about requiring a central nervous system.
Okay.
Thank you very much, Charles, for a beautiful talk and a thought-provoking discussion.